Guys, so we are going to use back the pre-recorded video. So yeah, so I need you to follow the lesson and do the sum of the questions and have to do some pausing in between just for today, right? Because I need to go somewhere lah, right? Which is very urgent. Okay, so today we have done on a few things. We have done on similarity, congruence, similar area, similar volume, alright, and then we look at bearing, if you still recall. Then that was what we learned last few days. So now we are moving on to something new we call as circle theorem, alright. So somehow it's very important, okay, it's something new to you, okay. So yeah, alright, but no worries, okay, it's quite interesting, okay. So but I break it into few parts so that it will be able to help you in understanding it, okay, somehow, right? So the first one, okay, we look at, okay, what is a circle? Okay, basically a circle is something that, okay, it's a round shape lah. It's a shape of a round shape. Let me get this thing for you. Okay, it's a round shape. Okay, so we know that in every circle, okay, every circle that we have one, okay, center point. Surely there will be a center point one. Okay, so there is a center point, and this center point is located in the middle of the circle. Alright, so okay, the surrounding of the circle, this is the what? This is the circumference. Okay, this is the circumference. I'm gonna put this color, insert. This is the circumference. Okay, circumference. Okay, so right, so now then, right, inside the circle, okay, we have a few lines that you have to know. One is that it's in between of the circumference to the circumference but doesn't cross through your center point. This line itself is called as the, what do you think it is? Right, it is known as the chord. It's a chord, C-H-O-R-D, right? So any line that crosses through the circle but doesn't pass through the center point is known as a chord. But if, let's say, right, it is a line that going through your circle from one circumference to the other end, but it passes through your center. This is the blue line that we're talking about. This is going to be your diameter, right? So actually diameter and chord are the same thing. Diameter is a chord, right? It's just that diameter is a special chord. That's why it is, okay, it is like that. So this is known as diameter, right? And then we also know that, okay, in every circle, diameter, okay, right? In a circle, if it's from the center to the circumference, this is going to be known as your radius, right? So radius, if there's a lot of them, okay, it's called as radii. So that's why in singular we call as radius, right? Radius, R-A-D-I-U-S, okay, but in plural, okay, it is known as radii. So I'm gonna write down here for you. Okay, so plural, plural is known as radii. Okay, D-I-I, radii. Okay, right, so this is the purple one. Okay, then, right, okay, if we have this part here that connecting a radius to another radius, so this is also another radius here, this part here, this is known as the arc length, right? This is known as the arc length. So we put green, arc length, right? So you have to know the wording because it's important. Later on we will use that a lot. Okay, whereas this region, this part here, where I put a lot of black lines now, right? This region here is known as a sector. Okay, right? So arc length is the length of it, but the area that is surrounded by it, that is the arc. It is the area of sector. That's called as a sector. So a sector is just a part of the circle. Arc length is a part of the circumference. So that's why, okay, you have to know the things. Okay, right? And one more thing is that when we cross over the circle, okay, and it only touches one point, nothing else, this line is known as a tangent, right? A tangent to the circle. Okay, maybe I put pink. I put pink. Okay, this line is known as a tangent. Right? Later on we will use that. Okay, a tangent is a line that only touches the circle, right, at one point, never two, always one. Okay, but we will look at that later on. So, but this is the things that you have to know at least, right, to understand this circle theorem. Okay, right now. So the first circle theorem, theorem is like a rule like that, right? Like it is something that you should know, right? That only happens in circle, right? So now we are talking about the angle subtended at the circumference. Meaning is that is the angle that it is formed in the circumference, okay, by the same arc. Which means that you look at this. You look at these two lines that we have. This line and this line. Right? It forms an angle, right? The angle is x, and the angle formed, right, is actually in the circumference, correct? Right, you see the angle touches the circumference one, and this is also another two lines that will form an angle, okay, that on the circumference also. Okay, so this is the green color one, right? If let's say these two green and the yellow one, they have the same arc length, the angle will be the same, right? Why I say so? Okay, I'm going to show you this geometric sketch pad. Alright, so have a look. Right, so this is your this is a circle, let's say. Okay, if let's say I have a shape like that, okay, you see the shape is like this, okay, and I also have another shape like this. Okay, let's say I draw, this is another shape that I have. Look that they have the same circumference. Look at this part here, they have the same circumference for both shapes. Both of them will have the same angle at this point here. So let's measure them. Okay, I'm going to measure them. This angle, let me call this one as A, B, C, and D. So angle ABC will be ABC, right? Will be, let's see, measure angle, right? It's 58.78. That's this part, ABC. Then angle ADC, right, is going to give us 58.8 also, right? Reason being is because they have the same arc length. But if you see, if I adjust the arc length to smaller arc length now, let's look at the arc length AC now, is the arc length. It's smaller already, right? You look at the angle at B and D, they are the same. So which means that as long as the arc length is the same, the angle that form, okay, by the two lines, right, at the circumference will be the same. So this angle here and this angle here will be the same, right? Okay, you get what I mean, right? The idea is that the arc length must be the same. As long as the arc length is the same, the angle subtended at the circumference will definitely be the same. So let's say, for example, right, you have my arc length getting bigger. You see, if my arc length getting bigger, my angle also getting bigger. You get what I'm talking about, right? That's why as long as they have the same arc length, angle will be the same. But the moment my arc length, right, double, my angle also will be double. Right? So this is one of the rule that we have, the first theorem that we have. That's why you see this one, right, like this shape here like that. This is the first shape that that form the X angle, the yellow one. Okay, this is the yellow one. Okay, and then I also have a green one, but both of them have the same arc length. How do I know actually? Do they have the same arc length? They start at the same point, end at the same point. That is the arc length. You see, right? This blue, green one and the yellow one start at this point, end at this point. They have the same length. Therefore, the angle will also be the same. Okay, this is the first theorem that I'm going to introduce you. When the arc length of the two shapes that appear in the circle is the same, then the angle subtended at the circumference will also be the same. Alright, so now let's look at this example, how we applied it. Alright, I want to find the value of x. So in order to get x, I just need the q. When I get q, I can get the x already. So but what is q? That's the question. Right now. Right? So now you see, based on what we can use the circle theorem, this is one of the shape that I have, right? That form the angle at q. Right? This is the green one, let's say. The other one I have is this yellow one. This yellow one. See? Then right, you see, they start at P, end at S. So both green and yellow, right, start at the same point, end at the same point. Therefore, the angle on the circumference will be the same. So as such, when this is 55, I will know that the angle at the bottom, at the other side, will also be 55. Right? So it will be 55. So let's see. Okay, it will be 55 here. You see? Therefore, right, why is it like that? Because same arc length ma. You look at the arc length here, P and then N as S. I'm talking about this length. They have the same arc length. From P, it moved to S. Oh, no. Oh no, sorry, I used the wrong thing. Right. Look at this angle here. From P, it goes to S. This length I'm talking about. They have the same arc length. That's why the angle will be the same. So therefore now you know that 55, right, plus 40 plus x will equivalent to 180. Right? So 95 plus x, right, will equals 180. Do your maths, alright? So x is equals to 180 minus 95 is what? 180 minus 95, you get 85 degrees. So your answer is 85 degree. Of course, there's a lot of way of to solve this problem. Okay, a lot of way. Okay, not necessarily must use this way, but your concept must be correct. Okay, right. So now let's okay, same angle because circumference the arc length the same, and both are on the circumference. Okay, right now let's try question number 2. Right, let's pause the video and try for a while. Okay, let's try let's pause. Right, so let's continue. Okay, so like I said, okay, let's look at this question here. You have the RS. Okay, you look at this angle. Okay, R and okay, this angle subtended at the center, at the circumference. Okay, this is the yellow one. Okay, this is the yellow one. Okay, then you will also see the question say that QR and RS is the same length, right? They say the question say QR equals to RS, which means that this angle here, this one, formed by this QR, okay, it's gonna be the same. Why? Because the angle formed at QR and RS is the same. This angle, this arc length, this one R and S, okay, and this QR, they are the same length because the question says so. These two are the same length. So therefore, when it's the same length, arc length, the angle here and the angle here at the circumference, right, will be the same. Therefore, okay, the angle at P, the other part itself, is 32 degree. So that is the angle. So this is 32. You see that? Right? So because of the same arc, pink color line length, that's why the angle formed at the circumference is the same. Then how do we find the x? Right? If you can see well, right, this is a radius. From center to the circumference is a radius. This is a radius. This is also a radius. Okay? If this is both of them are radius, meaning this is an isosceles triangle because same side, right? So if this is isosceles triangle, if this is 32, x will also be 32. So that's why my x is just 32. Answer is just 32. Get it? Right? Okay, arc length the same. That's why angle the same, form on the opposite side one. Then why is it 32 here? Because of isosceles, radius, same radius. This one you have to know, it's very important. As long as you see two radius together to form a triangle, it's definitely going to be isosceles because radius will have the same length. Okay? Alright, so that's the first part. Okay, now the second one will be, right, it's also the same arc length, but now instead of both of them, right, in the circumference, one of it is in the center. Okay, so now let's look at the geometric sketchpad now. Now, right, my circle is like that. This is my circle. Okay, right. Now my angle, my arc length is like this. This is my arc length. Look at this, this is my arc length. So I'm going to label this one as DEFG. Okay, so I measure the angle formed by this arc length first. This is my angle, EFG, 77.6. Okay, using the same arc length, start from the same point, but it's in the center now. Go to the G. So this is the center, right? I'm going to label this one as O. Okay, as O. Okay, the angle formed here now, the angle formed here now is in between of EOG. So measure, okay, what is it? I forgot to get the G. Okay, G. And measure the angle. You look at it, actually it is double, right? You can use a calculator to press, it is double the angle. So which means that if let's say I have the same arc length, okay, same arc length, but one in the circumference and one in the center, the angle formed at the center will be double of the circumference one. Just now it's the same because both of them are on the circumference, same arc length, both the same are on the circumference, angle the same. But same arc length, one in the circumference, one in the center one will be double. Okay, you can try 48 times 2 is 96.44 already. So it's double. Okay, so this is the second theorem that we have. Same arc length, but one on circumference and one center, the center one will be double. Okay, so maybe I write out a brief thing here, right? So times, okay, then, okay, times the paragraph 01. Okay, so I would say same arc length, right? Okay, one in the center, okay, the one angle in the center, one angle in the center, at the center, okay, at the center, okay, and one, okay, angle at the circumference, okay, okay, the angle formed, okay, at the center will be double, okay, double, right, okay, of the angle at the circumference. Okay, so this is the theorem that we have. Okay, so the other one is if the arc length is the same arc length, okay, one angle, both angle at the circumference, both angles, okay, at the circumference, both angles, the angle formed, okay, at this form, okay, will be the same. So the criteria is same arc length. Angle at both circumference, the same. But if it's one in circumference, one in center, the center one will be double. Okay, how do we apply that? Look at this diagram here. Okay, so this is one of the shapes that this is one of the shapes that I have, the yellow one. Okay, I'm gonna put yellow, right? And the other one I have now is the green one. This is the green one. Okay, maybe I move for the green one. Okay, so now you see, right, the yellow and the green one, they have the same arc length. This is the arc length. You see, start from the same point, but one in the center, one in the circumference. So the center one will be double of the one in the circumference. So the circumference one now is 35. So x will be 35 times 2. So which is equals to 70 degrees. So that's why the angle formed is 70 degrees. Okay, because the center one will be double of the circumference one. That's why it's 70. Okay? Yeah. Alright, now question 4. How? Okay, same idea. Look at it. Now, this is my line that I have. This is the line that I have. Okay, right? So, this is the yellow line. Okay, the angle that is forming here is this part. This is the angle. This is the arc length that I'm talking about. So the angle, right, will also be here, not the 130, but it's this angle. Because it's follow my arc length one. You see, every time it's following my arc length. So therefore, right, you see, this green line that I have, will also have the same arc length. Because this, even though that doesn't look like it, but they start at the same point and at the same point. Therefore, the angle here, okay, should be the same, right now. But the problem is, this is at the center, this is in the circumference. So therefore, if the circumference one is x, what is this? It's gonna be double of the x mark. So this is 2x. So here is 2x. Because look at the circumference, look at the arc length. This is your angle form here. So this is the angle form with the same arc length. Look at the diagram. So the opposite one, the one that formed in the center, will be double. That's why it's 2x. So the whole circle is 360. So we know 2x plus 130 is equal to 360. So therefore, I know 2x is equal to 230. Therefore, x is equal to 115 degrees. So that's why I have this answer, 150. Can? Yeah, say again, arc length, radius, okay, the one that form the angle, two lines, the arc length, the angle will follow the arc length, right? How you form? It's not 130, because if 130, this is your arc length already. Okay? Can right? If it's 130, the other side is your arc length, right? This is the arc length already. If it's 130, this is going to be your arc length. Then it will, if this is your arc length, right? Then this is going to be your angle. So your angle will follow your arc length one. Okay, but now we are talking about these two two parts. Right, maybe I put blue. Okay, so that's why the opposite one is this blue, is with this blue, because they're having the same arc length. Can? Right, you know what I'm talking about, okay? Right, now let's pause the video and try this question number 5. Okay, let's try this faster. Right, can? Alright, now let's look okay, I just draw out for you. Okay, we know that this angle, right, is formed at the center, and the radius, okay, and the arc length is the same, the yellow one. Okay, and the other one, the green one, is this one. See, same arc length. You have to use the same arc length, right? They start from the same point, end at the same point. But one in the circumference, one in the center. So we know that if this is 100, this entire angle will be 50, right? Why? Because one in the center, one in the circumference, same arc length, right? So we know that this line here, right, this angle here is 50. But I want to find x, I need this angle. How to get this angle? This is an isosceles. You see not? Radius, radius. This line is a radius, right? This line is a radius. This line is also a radius. So therefore, right, we have two radius together, okay, 30. This angle here also 30 degrees. Okay, because isosceles. So just now I told you this is 100. Here will be half of it, because one in center, one is in circumference, correct now. So therefore we know that x plus 30 equals to 50. So x is equivalent to 20 degree. 50 minus 30. So x is 20 degree. So we are done. Okay, actually circle theorem, if you are applying circle theorem, you don't really need to do a lot of work. Okay, you can see a lot of their application. Okay, right? So the last one is just also the same, almost the same thing, right? But now we are talking about a triangle formed in a circle, and one of the side, right, of the triangle is the diameter. You see, it is diameter. You see a triangle, this is a triangle, one of the side is the diameter. So therefore, the angle formed on the circumference, opposite to the diameter, will be 90 degrees. Okay, common sense. You see, look at it. This is the yellow line, this is the green line now. Okay, same arc length. You see now, this is the arc length now. This is the arc length. Do you see that? They start at the same point and at the same point for the green and the yellow line. What is this angle? What is this angle here? The angle formed here. 180 mark. This is at center. So the one that formed in the circumference one will be half of it mark. That's why this is 90. Actually, this theorem, right, come from the previous two. It's the same thing. Just that they want to make things easier for students to understand, right? For people to understand. They created another one theorem just to say that a triangle, one of the side is the diameter, then it's 90 degrees. Okay, so we are applying that now, right? You can see that this is a triangle. Okay, this is a triangle, and one of the side happen to be the diameter. You see now, the one that crosses the center O. Okay, so I know that the angle, opposite to the diameter, this is the diameter, right? This is the diameter. Opposite to it, this is 90. So I know that this angle here is 90. Okay, because diameter, this is the diameter, right? Opposite to it is 90, right? And I also know that this is an isosceles triangle. You see, this one is a diameter, radius. This is also a radius. Okay, therefore these two lines, right, are radius, makes an isosceles. Therefore, this part here, right, is gonna be x also. So, but I know just now, when I have a triangle and one of the side is the diameter, the angle that is opposite to the diameter will be 90. So I know x plus 30 is equivalent to 90. So x is just 60. So we got the answer. See that? Right? So we have learned 3 theorems, but they are almost the same one. One is same arc length, both angle formed in the circumference, their angle will be the same. The second one, same arc length, one in the circumference, one at the center. The center one will be double of the circumference one. Okay, if I have a triangle and one of the side is the diameter, then the angle formed opposite to the diameter will be 90 degrees. Right? So I'm gonna write down here, like maybe you can refer to later on. Okay. So I write down here. Okay. If there is a triangle inside triangle. Okay, we say inscribe lah, but inside the circle, right? Where one of the side, right, is the diameter. Okay, diameter. The angle formed, opposite to the diameter, right, will be 90 degrees. This one is to find okay, so this is the idea. Okay, alright, but you must make sure that the triangle must touch the circumference. If it doesn't, right, it will not be. Okay, alright, so we will stop here today. Alright, no exercise. We will do that when we have class together, because I need to see whether you understand or not. Okay, plus you have to really understand these three theorem. Then only I will proceed to the next one. So there are 3 things we learned today only. Okay, alright. So thanks. See you the next class.